Okay, so we're going to take a look here in this video on the ellipse that is centered at HK. Right? So here we have, let's call this the center HK. Now what's important to realize here is that the whole curve gets shifted HK units, H units along the horizontal, and K units along the vertical. So the shape of the graph remains intact. Right? So all of the other properties that we looked at in the video of an ellipse centered in the origin, right? The lengths themselves don't change, right? It's just kind of how we calculate them, right? Using distance formulas, right? Where we have starting point minus end point and just the absolute value of those things, whichever way you decide to calculate it, right? But the point is that the values themselves remain the same, just where it's kind of shifted and the numbers that you're uh, using to calculate distances, those change, but the actual values remain the same, right? So for instance, something like this, right, where we have something that is centered HK, which is wider along the horizontal, right? So that's in the case where A is greater than B. So same as before, the length of the major axes, this remains the same, right? That's going to be 2A. Length of the minor axes, that's going to be 2B, right? Now in this case, right, the minor axes would be the vertical, right? And each one of these distances is still B, right, from the center, right? So this point here, right, the co-vertice, here, this one would be H, right, same X value, but now the Y value would be K plus whatever that value B is, right? And down here, same X value, H, and then here we'll have K minus B. All right, and here we're assuming, right, B is always a positive value, and K would depend on where it is on our coordinate system. All right, so this would be our minor axes. And in this case, when A is bigger than B, our major axes would be along the horizontal this way. And then these points are our vertices here. And again, here the y coordinate remains the same. So here, in this case, it's still K. Right? And to get this unit, since it's along the major, it's 2A, so half of this distance is here. So it'll be H plus A. Right? And over here, we'd have H minus A, comma K. Okay, so those would be the coordinates of our vertices and the co-vertices. Okay, and now another thing here is how we relate C to all of this, right? The foci would be somewhere around here, right, along the major axes. Right? And same thing here, right? To get to this foci, it'd be H minus C, comma K. And here we'd have H plus C, comma K. Okay, all right. And to relate the C, A, and B values, we got C squared is equal to A squared minus B squared. Okay. All right, so that's the case where we have A greater than B here. Now, in the other case where we have B greater than A, okay, so again here our center we'll call HK. And now we have our minor axes to be along the horizontal, right, parallel to the x-axis. And we'll have our major axes to be vertical, parallel to the y-axis. Right, now, same as with our previous example, the length of the major and the minor, those remain unchanged, right? We're shifting the whole curve, right? So length of the major axes that is 2A, excuse me, 2B, and the length of the minor axis, that would be 2A. All right. Okay. And here for our minor axes, to get to this co-vertices out here, right, would be this distance, right, A. Right, so in this case here we'll have the K would be the same, but it'd be H plus A, K. And here we'll have H minus A, K. All right, so we're shifting along the horizontal, right? In other words, the x-coordinate is the one that changed by whatever that value of A is. All right, now to get to the major axes, that would be the vertical. To get to the vertices up here and here, all right, so that would be, in this case, the H remains the same, and what will change is the value of K. To get to this axis, it'd be K plus B, and then here, right, H remains the same, and it'd be K minus B. Okay, and then to get to the foci from the center, right, to get to the foci here, we'd have, again, H remains the same, and here we have, yeah, getting crowded in here. Let me just do an arrow here. To get to the foci, all right, the x-coordinate remains the same, and here we'll have K plus C. And then for this one, H remains the same, and we'll have K minus C. And that would be our second focus. All right. Okay, and same as before, to relate the values of A, B, and C, C squared will be B squared minus A squared in this case, when B is the larger value, right? Always minus the smaller value, right? Another way to think of this here. Okay, so notice doesn't change. All it changes is our frame of reference, right? With these additional values of H and K that we have to that we start with, right, as our starting point. All right. Okay. Next, we'll look at how to find the equation of a ellipse.